Good morning, everyone. Just want to work through some solutions to the indices problems I posted on Tuesday. So here's the first section, which I'm sort of hoping was relatively straightforward. Just practice with the indices rules. Remember, deal with the numbers and the letters separately. With K, you had to expand these two terms first. So this was what you got when you did 5r s squared cubed. You cubed the 5, you cubed the r, and you cubed the s squared. And this is what you got when you squared 10rs. So you squared the 10, square the r, square the s. And then we just use the indices rule. So we divide 125 by 100, r cubed divided by r squared, subtract the indices, r to the power of 1, just r, and s to the power of 6 divided by s squared is s to the power of 4. And with L, when you did the sum, the numbers, you had to do 5 divided by 1/5, which is the same as 5 multiplied by, sorry, you had to do 3 divided by 1/5. That's the same as 3 multiplied by 5/1, so it's 15. So that was that one. Right, the second section got a little bit trickier. So I know I'd sort of snipped this out of a larger section, so that's why the letters were a bit random. So so we were asked what 16 to the power of 3/4 is. I'm going to do this step by step. So 16 to the power of 1/4, that's the fourth root, that's 2. So 16 to the power of 3/4 is this cubed. So it is 1/4 cubed. D minus 125 to the power of 1/3, that's the cube root, so that's -5. And so to the power of 2/3 is this answer squared. And when you square -5, you get plus 25. I, when you square root a fraction, you just square root the numerator and denominator separately. So again, so I'm moving up. So to the power of 3/2, it's this answer cubed. And with J, 3 steps this time because it was a negative, so you've got the power of 1/3, so you just cube root numerator and denominator. Cube root of 1 is 1, so that was nice and easy. You then square that, so that's 1 squared and 6 squared. And remember, the minus power just means you flip it. So it becomes 36/1, which is just 36. And then the last two, one was a decimal, one was a top-heavy fraction. So it is much easier with the decimal if you write it as 64/1000. So the cube root of that, cube root the top and the bottom separately. So to the power of 2/3, it's this answer squared. So you square 4 and you square 100. And as they gave me the question in decimals, I guess it's polite for me to write my answer in decimals as well. And with the top-heavy fraction, with the mixed number, I wrote it as a top-heavy fraction, and then it's nice and easy. So square root, cube your previous answer, flip your previous answer. So that's the square root of the numerator and denominator separately. That is the cube of that, and then that is just this answer flipped over. So we then came to the 3 tricky ones. It was lovely that so many of you sent me your solutions. That's really nice to see. We're in a funny situation, aren't we, where, I'm not your teacher officially. Some of you I've never even met. But I am really keen that we do use this time well. So when I post you a bit more work and ask you to submit something, I would like everyone to do that. And if I don't hear from you, all I'll do is just drop you a quick line, phone you, and just say that, are you still planning to do A-level maths? I don't want to move ahead with everyone apart from a few of you who are then going to be at a disadvantage in September. And we are in an awkward situation, but we can use it to our advantage. Drop me an email if you've got any concerns about that. But anyway. So this was the first question. We are being asked to cube root, and hopefully you've got your flashcards stuck up in your toilet like I suggested. To the power of 1/3 means the cube root. And because I've got not 125 plus x to the power of 6. Remember from last week's or from Tuesday's video, you couldn't cube root those two things separately. Because we're multiplying here, I can just do this by cube rooting everything separately. So cube root of that, the cube root of x to the power of 6. What times itself again gives me x to the power of 6. X squared. And the cube root of 64 is 4. Nice and easy. So with this one here, have I written that down right? No, I haven't. I've missed off the cubed, sorry. There we go. So I'm going to firstly sort out this numerator. This is already nice and simple, so I'm going to write that down straight away. But here, again, like I did with the previous one, I'm going to cube these two things separately. Now, 2 cubed is nice and easy. 2 times 2 times 2 is not 6, it's 8. X to the power of a half cubed. Well, remember what we do with this situation? We multiply the two index numbers, so that gives me x to the power of 3 halves, 3 over 2. And a few of you got there, and that was absolutely right. But we can actually simplify this, because what I've got is a division sum. So I've got 8 divided by 4, well that's 2, and I've got x to the power of 3 over 2 divided by x to the power of 2. That's an indices division sum. I know I need to subtract the index numbers. So if I do 3 over 2, which is 1.5, take away 2, I get minus a half. And yeah, I mean, one of the things I think I'm going to leave until we're all together is explaining why that can be simplified like that. It's perfectly okay to leave it like that, but it actually means that, and that's perhaps something we'll leave for another day. And then the last one was another one of those ones I broke down into 3 steps. So this was the actual question, wasn't it? But I'm going to do it in 3 steps. So firstly, cube root, and we're multiplying here, so I can just cube root everything separately. So the cube root of 216 is 6. The cube root of x to the power of 6 is x squared. Cube root of 27 is 3. And the cube root of y cubed is just y. We then go to 3 over 2, so we're squaring. We're taking this answer and we're squaring, and guess what? I'm multiplying everything here, so I can just square everything separately. 6 squared, 36. Y squared squared is y to the power of 4. 3 squared is 9. Y squared. And then minus power just means flip it. And actually that one I can simplify as well. I can't simplify the indices because I can only use the indices rules when it's the same base. And here I've got y squared and x to the power of 4, so I can't do anything there. But I've got 9 over 36. If I think of that as a fraction, that's like a quarter, isn't it? 9 over 36 is 1 over 4. So I've got one lot of y squared over 4 x to the power of 4. Good stuff. Do you want to have something different? Okay. Let's move on one further step. It's really odd because for those that I taught, we revised this relatively recently. We revised it in the light of it turning up as a really hard grade 9 question on GCSE. That's now gone, but the good news is that it could turn up as an A-level question. Here we're being asked to write these 3 things as a power of 3. That's what this means, this rather pompous way of saying something. It just means write it as 3 to the power of something. And the thing you need to remember is the third index rule that says if you take something like 4 cubed and you take that and do it to the power of 5, you end up with 4 to the power of 15, 3 times 5. So that's the index rule that we actually use here. Because what I've got here in each of these questions is something that I can write as 3 to the power of something. So 9, in fact I'm going to grab a different colour for this one, 9 I can write as 3 squared. And 1 over 3 is 3 to the power of minus 1. And here's 9 again, that's 3 squared. So this first question, 9 to the power of x, is the same as saying, what's 3 squared to the power of x? And this next question, 1/3 to the power of x, well, that's the same as saying, what's 3 to the power of minus 1 to the power of x? And this third question, what's 9 to the power of 2x minus 1? That's the same as saying, what's 3 squared to the power of 2x minus 1? And I can use my rule here, because 3 squared to the power of x, well, I just multiply. I know that's not a number like I had here, but it's still just that times that. And here, that times that. And here, I've got to do that times all of that, so I've got to do 2 lots of 2x and 2 lots of minus 1, so I get and I know this is really odd and abstract. I know 4 to the power of 15, I know that's a really big number, but I could work it out. But I know that here we're into really abstract things, but that's A level. We're learning to sort of develop our confidence with algebra. Okay, so the next step is to use that to solve equations. Here's 2 examples of equations. It's again rather pompous way of writing the question. Find the value of x such that, and this means solve it and work out what x is. And in this question, I can't help noticing that 64 I can write as a power of 2. So if I go through my powers of 2, 2 squared is 4, 2 cubed is 8, and then I've got 16, 32, 64. So that is 2 to the power of 6. So what this equation becomes is I've got the same base on both sides. I've got 2 on both sides. This equal sign tells me that this has got to be the same as this, so I know that x has to be 6. Over here, I can't help noticing that this can be written as a power of 5. So that equals that, got the same base, so these 2 powers have got to be the same. So I know that x minus 1 has to be 3, so that means that x has to be 4. And yeah, hopefully you can now have a go at the questions I have attached to this, either sending it to you as an email or putting it on class charts. And I'm not going to ask you to submit any of this unless you want me to answer any questions. But I'm going to post some more on Monday, and I will ask for a submission after that. Can I just say the third question, sorry, not the third question, the last question on today's work is a real head scratcher. And it's sort of based around this, but it's just for those of you who are feeling really confident and really want to get your teeth into something, you can have a go at. So just be aware, the last one, sorry, is a real head scratcher. And certainly I'd be delighted if you managed to solve that one to see your answer. Solutions to these on Monday, along with something new. Hope you're all well. Take care.